I'm going to run an analogy across you about germination and in comparison to autism. And
Mm,
maybe I'll just do it now.
yeah.
I'm your student right now. So I want you to be a tough professor on me and to just correct me if I'm wrong. So I want to lay out that so artificial light came around, let's say 1890s, let's just say 1890s. Autism first showed up in 1930. Johns Hopkins, Leo Kanner, and then in Vienna, Hans Asperger. They were studying this at the same time. This is like one to maybe two generations after artificial light. So I'm thinking, like, if as a comparison, if I'm trying to grow a tomato plant, right, and I have the seedling, and I put in the soil, and I have to nurture that up and eventually get it to sunlight. If I don't get the sunlight, it's not going to develop, right? It's going to be underdeveloped.
Hmm.
And that's what neurodevelopment is. That's what autism is.
Hmm.
But in comparison, if I give it the proper environment, it has a better chance of developing into an adult plant.
Hmm.
So my question is, maybe I should have started with the artificial light, but how much of the this energy coming in is responsible for the development of, let's say, a fetal or that plant?
Hmm. I mean, excellent question. And I've been really trying to bring this to light, no pun intended, about the role of the environmental information. And it's not just, like pollutants and things like this. The environment itself carries information for our development. The biggest myth is that our internal surfaces are dark. They aren't. There are receptors in places that are within deep brain region, within the fetus, for example, within the womb, that's supposed to be dark, but it is kind of red shifted. There's a glow of red within those areas, and these opsins are within the brain, for example, like neuro. There's other proteins and pigments like neuromelanin that are also photosensitive and photoreactive. So there's a big question mark. Why are they there? Evolution doesn't like to waste energy and is pretty efficient. And if it wasn't useful, we would have evolved out of that, right? So to answer the first part of your question, there's definitely some sort of role in there. In terms of light, the light that we absorb from our environment carries energy and information. And the information is not just in the intensity of light, it's not just in the wavelength of light, but in the pattern in which we get that light throughout the day. So, we see this often, for example, in shift workers. In shift workers that have, it's not just circadian, it's not just the fact that they're not going away, it's not their metabolism, it's the exposure to the light, the pattern of light that they're getting. The receptors and the biology is reactive to this. So we don't exactly know what's happening on our internal structure in neurodevelopment, but within plants, for example, we know that plants need sunlight and they need light to grow. And if you pulse the light in very different patterns, you get all sorts of different shapes and growth patterns of these plants. You can keep the source of the light the same, but if you change the pattern, you get a different outcome.